Hello class, how's everybody doing today?
Good, how are you?
I am so great. Thank you for coming to class today. So we're going to be learning about valence electrons. Can everybody see the screen?
Yeah.
I can't. So I'm going to do a little bit of review. Can someone tell me what atoms are made of? What three components atoms are? I'll give you a hint. They're positively charged, negatively charged, and neutrally charged. Casey.
Protons, electrons, and neutrons.
Yes, you are so correct. Good job, Casey.
Thank you.
So, this is just an image of a random atom. This is not what all atoms look like, but you'll notice that the nucleus, it has protons and neutrons. The protons are in blue, and then around here are the electrons. So the electrons are on the outside, and the nucleus is on the inside with the neutrons and the protons. So, like I said before, not all atoms have exactly 6 electrons, exactly 4 protons. They could have a varying number of components in them. So it kind of makes logical sense. If a bigger atom has more protons or electrons, it's going to be bigger. And if it has less protons and less electrons, it's a smaller atom. So I made up these elements. One element is called Santa, and the other element is called Elf. So, just from your knowledge of Santa and Christmas and elves, which element do you think has more protons? Manny. Santa, yes, you're right. And why does Santa have more protons and electrons?
Santa's a bigger individual than an elf.
He is, but also because Santa is a bigger atom than Elf. So he has more, you're exactly, more protons and more electrons in Santa as opposed to Elf. So I made these up, but these elements I did not make up. This is the periodic table of elements, and these are real. And you'll see that it starts over here at the top left with a number 1, and around it is like a little box that has the letter H. And so this is one element, and it's different. All the elements are different. They have a different symbol and a different number. But over here, the top number, that's your atomic number. So over all of these letters, there's a number. And that means that, so let's say hydrogen, his atomic number is 1. And the atomic number tells you 2 things about atoms. It tells you the number of protons and the number of electrons. So you'll see if you go and progress through the numbers, you go from 1 to 2, 3, 4, 5, 6, 7, 8, 9, 10. The numbers keep getting bigger as you go and progress through the rows. So if the atomic numbers get bigger as you go through the periodic table, what do you think that says about the size of the atom? So, like we said before, bigger atoms have more protons. And an atomic number is the number of protons that an atom has. How big would you say, or like, do you think boron or carbon would be bigger? Carbon is bigger, and why do you think it's bigger?
Because it has a bigger atomic number.
Yes, that's true. You're so smart. Thank you so much, Manny, for your contribution. So what about, calcium over here, number 20, or magnesium? Casey, which one do you think is bigger?
Calcium.
Calcium. Yes, exactly. Why do you think that?
It has a bigger atomic number.
Yes, exactly. Oh my god, you guys are getting this. I'm so happy. Thank you. Okay. So bigger atoms, they not only have more protons, but they have more electrons. And I always said that earlier, but what I want you to focus on is the electrons at this point. So let's go back to the periodic table. So I'm going to post this question. So let's look at oxygen. Oxygen is atomic number 8. Do you think oxygen has more electrons, or do you think fluorine, atomic number 9, has more electrons? Maddie, what do you think? Fluorine, yes. And why do you think so?
Because its atomic number is slightly bigger.
Yes, that's very true. So it's this kind of the same thing about the size of atoms as well. They get bigger, more protons, more electrons. So let's go back to our atom. And we'll see here that, again, we have the nucleus, but the electrons, they're kind of in these rings. So here, this inner ring, this is kind of like an electron shell. And this is where the electrons go. This is where they are in the atom. And then there's another ring. This is like a second shell, and this is where more electrons can go. So electrons go in the electron shells. But you should keep in mind that they're not in the nucleus. The electrons aren't in the nucleus. They're distinctly apart from the nucleus. So let's go back to this. So this, you'll see that there's two rings here. One of them is on the inside and one of them is on the outside. So these are different. The electrons on the inside are different from the ones on the outside. And we actually have a special name for these outside electrons. And the outermost electrons are called valence electrons. So this is the meat of what we're trying to figure out here. So why are valence electrons so important? The reason why they're so important is because they're involved in bonding. So what do you think would happen if atoms did not form bonds with each other? Any ideas? Just throw out a guess. If atoms didn't form bonds, then that means you would only have individual atoms just floating around in space. And I wouldn't exist, nothing would exist. Like, atoms need to form bonds to be able to make things, and you are composed of atoms that form bonds. You're not just one little atom, you're a bunch of them. So it's very important. Atoms in bonds are really nothing. So how do we find the number of valence electrons for each atom? So there's a way to do this, and the first thing you're going to do is number your periodic table from 1 to 18. So you're going to start by numbering starting at 1 in the first column on your left, 1, 2, all the way up to 18. And you'll notice that the first column has a number 1 over it, and that means that all of the atoms in this column have 1 valence electron. So the second column means that all of the atoms in this column have 2 valence electrons. So Casey, what do you think that means for the third column?
I have 3 valence electrons.
3 valence electrons. Well, I can see why you would say that, but we're actually going to kind of put to the side this middle section in the periodic table and rather move on to the next column. And that's going to bring us to our 13th column here. So, Maddie, how many valence electrons do you think the 13th column of atoms has? 13. I could see why you would think that, but actually, it's not 13. The answer is a little bit more complicated, and it has to do with electron shells. So like I said before, electron shells are where the electrons go. Those are those little rings around the atoms. And they don't fill in just like one at a time. They fill in like the first shell can only have a maximum of 2 electrons, and the second shell can have a little bit more. It can have a total of 8. The third can have even more. It can have 18. So I know that sounds kind of weird to think about right now, so let's apply it to an example. So let's say boron. Boron is atomic number 5, and there are some distinct steps that we need to go through to figure out the number of valence electrons that boron has. So the steps that we're going to start taking are asking yourself, which atom are we looking at? So you have to be able to know and find where boron, or B, is on the periodic table. And we know we can find it just by looking at it. It's right here. And the second question you're going to ask yourself is, how many electrons does the element have? And finally, you're going to start placing the electrons in their shells. So we already know we're looking at boron. But Casey, can you tell me how many electrons boron has?
Has 5.
There's 5, yeah. And how did you know that?
Because the atomic number is 5.
Yes, correct. Awesome. So now we're going to do our most important step, and that's where we place our electrons. So, like I said, the first shell, that's the most inner one right here, that can fit a maximum of 2 electrons, and I put that key up for you to look at. So the first shell can have a maximum of 2 electrons. So we're going to go ahead and put 2 electrons from boron in the first shell, and then we're going to move to our second shell and put in the remaining electrons. So we're going to put in 3 electrons to the second shell. So you'll see 3 electrons over here, and then 2 in the first shell. Do you guys see that? Okay. So So how do we check our answer to make sure we get this right? So what we do is we add up the electrons in the first shell, which was 2. We add the electrons in the second shell, which is 3. And then we add those together, and that answer should equal your atomic number. So 2 plus 3 is 5, and that matches the number of electrons and the atomic number of the atom. Does that kind of, are you seeing some patterns here? Great. So the outermost shell has 3 valence electrons. We knew that because we put 2 in the first one and 3 in the second one. But it wasn't 5 because we put 2 in the first and 3 in the most outer shell. So let's do another example. What we're going to look at is carbon, but let's go through our steps first. So the first step, Casey, tell me which atom we're looking at.
Carbon.
Carbon. Okay, great. So Maddie, can you tell me how many electrons carbon has? 6. Good job. Okay, finally we're going to start placing our electrons in their shells. So Maddie, tell me how many electrons will go in the first shell? 2. Great, awesome. And Casey, how many will go in the second shell?
4.
4. So who can tell me how many valence electrons that carbon has? How many are in your outermost shell?
4.
4. Okay, so like I said before, valence electrons are the number of electrons in your outermost shell. So it's not, it doesn't have 2 valence electrons, it doesn't have 6, it has 4 because that's what's in the most farthest out shell. Okay, and now we're going to look at nitrogen and go through the steps again. So we're looking at nitrogen, that is in this column. And Maddie, tell me how many electrons nitrogen has?
7.
7, good job. And Casey, how many electrons would you put in the first shell?
2.
2, okay. And Maddie, how many would you put in the second shell?
5.
5, good job. So who can tell me how many valence electrons nitrogen has? Casey. 5, good job. Thank you for raising your hand. 5 valence electrons. So could anybody tell me, I know we're not going to go through the steps for this one, but maybe just from the patterns that you picked up throughout this lesson, how many valence electrons would you think that oxygen has? Since oxygen is over here. We just did carbon and nitrogen, now we're doing oxygen. So if carbon had 4, nitrogen had 5, Casey?
6.
6, yes, good job. And Maddie, what about fluorine? That's
7.
yes, it would be 7. Good job. So how about neon, Casey?
8.
8, yeah, that's right. Good job. Now let's switch things up here. Let's look at lithium. Can you see that? Lithium. So how many valence electrons would lithium?
1.
1, yeah, good job. Exactly, it's 1. So were you tempted to say 3?
No.
No. Okay, good. You guys are like actually learning. I'm so happy. Okay. All right. Let's do one that has a lot of electrons. So this one is chlorine. Okay, this one is chlorine. We're going to go through the steps here. So we're looking at chlorine. How many electrons does chlorine have? 17. Good job, Nate. So how would we start filling our first shell of electrons? How many would we put there? 2, yeah, we would put 2. And how many do you think we'd put in the second shell?
8.
8, yes. Yes, good job. Okay, now how many do you think we would put in the third shell? 7, yes, good job. So how many valence electrons do you think that needs for this chlorine atom?
7.
7, yeah, good job. And we know that because we add the electrons from all our shells up, and we get that to be the element's atomic number, which is 17. So, all matches, yay. Great. All right, so let's look at magnesium. Can someone tell me how many electrons magnesium has?
12.
12. And how many valence electrons does it have?
2.
Yes, good job. Okay. All right, let's look at aluminum. So someone tell me how many electrons aluminum has? 13. And how many valence electrons?
3.
3, 3. Yes, good job. Okay, and now we're going to do helium. So this one is over here in the top corner. Okay, that's in the top corner. So someone tell me how many electrons it has.
2.
2. Okay. Now, how many valence electrons does it have? 2. Yeah, that's right. You sounded unsure of yourself, but you were correct. Well, thank you guys for watching my lecture. I hope you learned a lot, and I really enjoyed teaching you. Will you pause that?
What's your password?
764. That wasn't recording. Oh my god, I would hate that. Thank you guys so much for